Okay, as ever, this call is being recorded. As we know, a lot more people watch it on YouTube after the fact than drop in. We'll get started. I'm sure we'll see a few more people drop in during the session. Today, although there's the kind of topic of the Aptainer release, which we'll get to later on, we're going to start off with a little bit of a demo to get back to our pattern of showing things you can do with Singularity CE and projects around it and so on each month, so that we kick off with something for people who are more users rather than developers of the software. So what I want to demonstrate today in this little first session is something dealing with using containers on multiple architectures, working across different systems. Now, you can compile a Singularity and install it on any of the kind of main architectures that Linux runs on today. So people do this on AMD 64, of course. There's ARM machines from Raspberry Pis up to sort of the big AWS Graviton instances and HPC ARM instances. The Fugaku supercomputer uses Singularity Pro actually, but that's an ARM system. And then PowerPC is also supported in their deployments to that. Now, the kind of issue with the diversity of architectures, which is coming back into play now in the HPC world and more generally, is that you only have one type of architecture on your desk. Maybe your laptop is a Windows machine with a Linux VM in it, and it has an Intel or AMD chip. Maybe you have an M1 Mac and you have an ARM chip in there, and you're running an ARM Linux VM, but you need to build containers for another type of HPC system, and you want to do that locally. It's not always been very straightforward to do that, but in Singularity 3.6, the Singularity code started to honor a feature of Linux where you can register alternative interpreters for types of binaries. There's something called bin format MISC, and this kind of support in the kernel lets you register that binaries belonging to a certain architecture or with a certain executable type should be run through some kind of different interpreter. And the QEMU project provides static user mode binaries which emulate different processors and systems. And when you put these two things together, what you can do is run ARM binaries on an Intel chip and vice versa, all the different combinations. And container runtimes can kind of make use of this and support it to kind of make things a bit more transparent across architectures. There are downsides, of course, and we're going to look at the main one, which is speed, a bit later. But I want to just go through some examples of how this type of stuff works. So I'm going to share my screen and stop my video a second, and we will get started. Okay, so on the meeting minutes here, there are two links to different ways of setting up this QEMU user mode emulation. The first one is to use a container to do it. The second one is to use kind of Debian packages. These are just two ways of doing things. Most people would probably use the first container one. We go to this GitHub repository, which is linked. What this is basically a packaging of the QEMU static user mode emulation binaries for all different platforms, architectures like ARM64, 32-bit ARM, PowerPC, all these ones that you'll see here in this image are included. And what you do with this container is you run it in a privileged mode, and it will register all the interpreters for these different architectures with the Linux kernel's bin format MISC functionality. And they show in getting started, you can do this with Docker. But if we scroll down, this project is also showing how to do it with Podman and Singularity. So as long as you can run Singularity as root, because it needs privilege to set this up, you can use these commands. You run this one and it sets up all this emulation binary stuff for you. And then you can actually just Singularity run some kind of foreign architecture container and it should work. If you don't want to use a container to set this up, then distributions have packages that accomplish the same thing. So in Debian, there's some packages and a program you can do to do that configuration. Let me jump across a second to a terminal. And we'll see here that I am sat on a Linux machine with Xeon processors. So it's an AMD 64 architecture. Now, what I've done is I've used that approach to register the bin format MISC support, okay? And then I can go ahead and sort of cross-build containers. Well, how do I do that? If I look in the directory, I have a Singularity file called demo. So if I have a look at this one, what we'll see is that I'm bootstrapping from a local image in this case, although it could be a Docker repository or whatever. And my from shows that it's an ARM64 starting point. So I'm on my AMD 64, my Intel Xeon machine, but I'm doing a build that starts from an ARM container. And then I just have a simple post script and a run script here. So if I want to build this container, I can sudo singularity build my demo sif from my Singularity demo file. And what I should see is that behind the scenes, everything automatically happens so that the container I'm building, which is an ARM one, is run through these QEMU static kind of emulation. And then in my postscript, you'll see I'm actually kind of working then as an ARM 64-bit architecture, but I'm on an AMD 64 machine. And it's really that simple to build a container for ARM on your Intel machine. I can also run the container. And it will tell me that in the container, the architecture is ARM64. I can also prove to you that this will really work on a genuine ARM machine by SCPing it across to a different computer. And when I jump over there, when this image has come across, we'll see that this computer is a Raspberry Pi. Raspberry Pi 4. So this is an ARM machine and it's running an ARM64 Debian. My demo sif that I copied across from my Intel machine is here. And I can, Singularity run demo sif. And here we go, that container is working on my Raspberry Pi. So really very simple. Once you've got this emulation support installed to cross-build things. So any questions before I kind of go onward to talk about the limitations of this? All right. So the main reason why people still want to use native machines, like actually work and build on an ARM machine, rather than doing cross builds in this fashion, is related to the speed. So the user mode emulation is essentially emulating a completely different processor in software. So that can never be as fast as the processor running in hardware. If I do that NeoFetch, which shows the details of my machine, I have a 48-thread Xeon E5. It's an older generation, but it's pretty fast, okay? And in my demo folder, I have some benchmark images that I've set up earlier. So if I run the AMD 64 version of Sysbench's very simple CPU benchmark, and I'm using one thread only here, but you could run it with multiple threads. We'll see that it says CPU speed, events per second, 930, okay? Great. What happens if I run the ARM64 version on my Intel machine? Well, we can wait a little bit and we will see that we get CPU speed, events per second, 110. Now, if I run these multiple times and things, we'll see that there's a pretty reproducible evidence that you've got a order of magnitude difference, right? It's an order of magnitude-ish slower when you're using this emulation. If I jump across to my Raspberry Pi, I can run the Sysbench ARM64, and this is natively on ARM. And rather than the 110 events emulated on a beefy Xeon CPU, I see a huge number here, okay? And this is also indicative of other things when you're working cross-architecture and looking at benchmarking, right? So this number here says 1,492 events. So it's more than 10 times faster than the emulated one. But it's also bigger than the number I got for native AMD 64 Sysbench on my Xeon machine. And I know that the Xeon machine is a lot faster than my Raspberry Pi 4. The CPUs are much faster. But the way these benchmarks work, the differences between the chips and things, a very simple benchmark doesn't give you the full speed story. If you're comparing emulated ARM versus real ARM, then you can look at the numbers. But if you go cross architectures, it's really quite hard on very simple benchmarks to make a good comparison. You really need to use workload specific things to really pull out the differences. But I think what we've hopefully shown here is that you can relatively straightforwardly set up a machine which has Singularity on it so that you can build containers for a different architecture. You can transfer them to that architecture and run them. And we could do it the other way around if we wanted. We could build an AMD 64 container on the Raspberry Pi and bring it back. And that's what people might be doing if, say, they run an M1 Mac and they have a VM running ARM Linux with Singularity, and they want to deploy on an Intel or AMD compute cluster. That flow is available there. Okay, and any questions or comments or thoughts about this stuff? Okay.
Hi, David. Carl here. Is there any reference material we can read up more about what you're demonstrating here? In particular, you know, with a cluster that we can't upgrade due to cost, you know, we're still down level on glibc. Is this something that we can nonetheless use on a shared system with a down level glibc?
So Yeah, you can. The support goes back quite a long way for doing this. But as long as you can run Singularity on your system and it's supported, and you've got this bin format MISC support in the kernel that you're using, then this cross-architecture stuff does work. It doesn't, it's not letting you kind of bypass having a very old host system, but you have to have the current versions of Singularity running on your host system.
Okay, got it. Thank you.
Okay, I'm going to move on now down the agenda a bit. We've got a brief recap then of the Singularity CE 3.9 release. 3.9 went out a few weeks ago, and then was followed relatively shortly after by Singularity CE 3.9.1. So that came out 10 days ago on November 22nd. 3.9.1 was just a security release for the 3.9 series. Essentially, someone discovered that there was a vulnerability in the OCI distribution specification. That's what's used when you communicate with OCI or Docker registries and you pull images from them. The way that's done is informed by this specification. And there is an issue in the specification, so that there could be type confusion between the types of documents that you can get from a registry, because it was possible to have both manifests and layers fields, and interpretation of what you were given depended on content type headers. And this isn't great because it's then ambiguous how documents that present with both manifest and layer fields would be handled. Generally, sort of type confusion isn't a direct vulnerability, but it can be kind of coupled with other issues to give an exploit. So this one is something which was patched in Docker. We use the same libraries interacting with OCI registries as Podman does. So we brought in the fixes in those libraries. All our dependencies related to handling OCI images were updated. And that's the reason for 3.9.1. The 3.9 release as a whole, we've been over in meetings before. It was quite a big release with a fairly long changelog, some change defaults and behaviors, which we encourage you to read through, and a bunch of new features, support for C groups v2, different ways of specifying bind mounts, experimental support for an alternative method of setting up GPUs using NVIDIA's own tooling and things like that. Won't dwell on that too much here, but the other thing to point out is that with 3.9.1, shortly after we made that security release, we posted packages, RPM and deb packages. So we're now building in our CI environment Debian packages, which are natively built on Ubuntu, Bionic, and Focal, and RPM packages natively built on EL7 and EL8. These packages are kind of built on these distros. You'll actually find that they will install on many newer versions, and it will operate correctly, but we aren't directly testing that. So these are the four we're kind of testing, and we've got packages built for now. Every release going forward is gonna have these available for download. They've got a bit of a funny name here with a +6 and a git commit in there. The reason for that is that because there was a security release, 3.9.1 went out quite quickly, and the packaging stuff was done after. And that +6 just references the commits that put the packaging stuff into the code base. So there's no change to Singularity itself with that additional kind of version information. Any questions about the release or the packaging?
Starting with the next release, they won't have those extra.
Correct. Yeah, the next one, like a 392, will just say 3.9.2. It'll just take the tag. We could have sort of fudged it a bit so it would look neater, but we decided to be accurate with it exactly how the version information is calculated by our scripts, which build the packages. Okay, so the next thing to get on to is something that's been causing a bit of excitement and chat around the community, and that is the announcement of Apptainer. And what this is that the other side of the kind of fork of Singularity where Sylabs forked Singularity CE, and organization called HPCNG continued on the other side of the fork. Well, the HPCNG side of the fork has announced that they are renaming to Apptainer, and they're moving under the Linux Foundation as a Linux Foundation sub-project. So before we go too much into the detail of what this means for CE, I'll give a little bit of history. So Singularity originated with Greg Kurtz's work when he was at Berkeley Lab, US government lab. And after some time and growth, Sylabs was established, and Greg led Sylabs, and work on Singularity happened majority in Sylabs with community contributions, and that's where the project sat. Back a couple of years ago, Greg left Sylabs and he founded a new company, and he went there. And when Greg left, Sylabs moved the Singularity code base that had been in the Sylabs kind of area on GitHub into a place called HPCNG. And HPCNG was sort of a third-party organization. Neither Sylabs nor Greg's new company. And the intention was that kind of collaborative development would occur there. Now, about a year after that move into HPCNG, Sylabs decided to fork Singularity back. So at that time, in May this year, we created the Singularity CE fork, and there are various reasons why that happened. I don't want to go into it too much here, but the fork came to be, and we have been doing our development work in the Singularity CE side of the fork. And HPCNG, the organization, went forward with their side of the fork. Now, what's happened with the Apptainer announcement is that the HPCNG side of things has renamed. They will be releasing under the name Apptainer, their next version, not Singularity, and it's a Linux Foundation sub-project. Okay, so there has been some questions out there, some discussion about what this means. In the Apptainer announcement itself, some of the points which were raised by the Apptainer community as announcement directly kind of reference Sylabs. We're lucky here, Dave Dykstra, who's joined this call, is heavily involved in this. He's one of the maintainers, and we've had an ongoing relationship with Dave, where we work together even after the fork. We communicated around some of the PRs and things which have been merged between the sites. In response to one of the kind of questions about what the relationship is between Singularity CE and Aptainer, I wrote something on Reddit, which has been linked on Twitter, and I've tried to be fairly straightforward there and as short as I could, pointing out a few things. So the first thing is that the Sylabs commitment to Singularity CE absolutely remains. We are absolutely committed to the open source project, and we make available our code open source. If we look at the development work since the fork, it's probably fair to say that Sylabs has performed the majority of the feature development and a large portion of the bug fix and maintenance work. And this has been available. If we go and look in the Aptainer side of the fork, we can see that that side has been pulling in the majority of our work. If we jump over to our repository, we can also see that we've been pulling in fixes from their side of things. So we have a list of stuff kind of we've picked in. Another way of looking at this is we can see that if we go to the Aptainer repository and we look at the kind of commits here, then we have some Sylabs people are at the top of what's been going in there commit-wise. And similarly for the SIF image format implementation, we have that too. Now, this is really kind of showing that Sylabs has, we really are committed to the open source nature of the project. We have continued to release everything under the same BSD license, and the HPCNG side of the fork and Aptainer are absolutely welcome to pull these things in. And I think because the HPC community kind of favors stability and moves relatively slowly, we haven't really diverged much yet. If we go and look at the Aptainer code base, which they're kind of preparing for a 1.0 release, it's very, very similar to what we've released as Singularity CE 3.9 recently. There are some notable differences which are going to be apparent in the announcement about Aptainer. And that the kind of main thing that you might find here is that Aptainer is going to remove support for accessing the Sylabs library and remote builder. Other than that, and Dave can kind of maybe correct me if I'm wrong, I don't think there's a great deal that will differ between CE 3.9 on our side and Aptainer 1.0.
Yes, I agree with that. That's we're trying to take advantage of anything, any work that anybody does on it. So.
Okay, great. So our kind of position here is that really nothing has changed in that type of relationship. Nothing has changed in our commitment to CE. We're going forward and we will be working on Singularity CE 3.10, which will be released in about 6 months' time on the normal time scale. There's sort of no impact either on the relationship with Singularity Pro and how that's built. The Aptainer announcement does make some references to Sylabs directly. There's calls, for example, for us to use Aptainer as an upstream, or potentially think about getting back involved in a joint project And what we're kind of doing at the moment is watching what happens. So if we look back, one of the reasons that contributed to our decision to fork from HPCNG was some things around how long it took to establish non-draft governance and so on. And there are many reasons, but that's just one kind of contributing thing. It's definitely a positive as we look in from outside, that the Linux Foundation kind of structure ensures that there's a steering committee, a technical steering committee, and there's a technical charter, and there's a very kind of defined governance. And that's a definite kind of plus point that we are very aware of, and we're happy to see. The comment around kind of switching to Aptainer as an upstream, that is something that will depend on seeing how things develop in coming months into the new year. Essentially, to use a different project as an upstream, we would have to be confident that the kind of the roadmaps, the directional features and everything accords, and that there's significant development resource kind of being put in there along those lines. I think we can, sorry, I'm admitting something here. I think it's definitely fair to say and visible that Sylabs has put in the majority of the coding effort in the 3.9 cycle here. And we've tried to develop an open roadmap for going forward and so on. And this kind of call about getting back involved in the project from a development point of view, we have to see and watch how the governance structures get established and how work is being done in the project, and how the roadmap is being decided and what's on it and things like that. So, I mean, to sum up from our point of view, we see some very promising kind of things with this Aptainer announcement. For Singularity CE and for our pro customers, there really is no change. We kind of continue as we are. There's no change to licensing here. It's still the same license on both sides, so code can move between. And then for the specific things, we've been referenced in the announcement. We need to watch what happens and can consider over time in the new year how things develop in the project. So that's what kind of I've got to say from our side. I don't know whether Mike or Adrian want to comment, or Dave, if you want to ask anything. We're basically open to questions about this this situation, and we can chat about it however you fancy.
I wanted to say that, I mean, the fact that we're moving lots of things back and forth between them is a lot of extra work. So I hope to like to be able to avoid that, for one thing, and also would like to see you at least starting to get involved in the discussions about what the roadmap will be and all that kinds of thing, rather, and be starting to become involved in the community. I think that this is the Linux Foundation is a really good base for a community, and would really be a lot better to not have a fragmented community, but to have one.
Yeah, like I said, I think from our point of view, things will be a lot clearer in the new year as we watch. I think when projects fork or when things get renamed and so on, there's often quite a flurry of activity. around kind of renaming and the logistics of doing that type of stuff. And it's going to take a while for the Aptainer project to kind of get through that bit, and then for us to be able to see what the normal kind of development flow and so on is there. So I think we're focused on going forward into Singularity CE 3.10 with features and improvements. The code's going to be available, and we'll be definitely watching very, very carefully and with great interest what's going on with Aptainer.
Well, I think that's encouraging. I'd like to. I think it would really be better if we could have a unified community and be able to really clearly say what the difference is between the. I think we'd still have a Singularity CE, but it may be very well better defined what the difference is. Do you have any questions for the Aptainer side?
I guess the one thing that jumps out at me is why was there a decision to go for Aptainer 1.0 for the first release rather than kind of follow on the figure? I think to my mind that's possibly going to be a bit confusing. I don't know.
Yeah, that decision was made like an hour before the actual release. So we were debating that choice. Some of us were trying to go for just continuing on, and others were wanting to start fresh. And so the reasons for the towards the starting fresh side was one was, well, yeah, it's hard for me to represent that side because I was arguing for the for the staying continuing on. This is simpler, but it was more, I think, to be able to more clearly differentiate the two projects. It still could be easily there'll still be a mapping for between them, between version line. You could say, like, now, for example, 3.9.0 is similar to 1.0.0, but people will just need to be able to better tell that. I mean, they will have to look it up instead of just trying to make assumptions based on the numbers, because otherwise people can also be confusing the other way, where people could say that, oh, this one's 4.0, that's better than that 3.10, even though it's not necessarily is, and so this way it should be more obvious that people have to really go and go look up what the mapping is instead of. So that was one of the I think the things that persuaded people. Plus, to just be able to get started, be clear from
Gotcha. And I guess there's one other question. There's been some chat, and with regard to the removal of the kind of library access, I'm curious whether you can confirm whether that's entirely that the library protocol will be completely unsupported, or whether it's that the Sylabs library will not be default and so on. And the reason I ask is because though it's not an open spec, we have had open source clients out there which kind of do implement the protocol, and there's more than one project where people in the community have built a registry which uses this protocol. So I wonder whether you could be clear on whether it affects those things as well, or if it's just related to the Sylabs cloud defaults and so on.
That is also under debate. And I think it really would be helpful if we could have a discussion between the maintainers, the technical steering committee, and Sylabs about how we could make this work best for the users. I've been advocating that I think we really need to at least have the library://read URL still work, because there are so many things that people have already by default. I would like to see that still work, to be able to download files and one way or another by default from the Sylabs public library, because there are so many things in history that are already referring to those URLs, so many posts and examples and things doing that, and that people are accustomed to that. And there will be people that are having a mixed in their community of people running the Singularity CE, Singularity Pro, and Apptainer, and we want them all to be able to work with the same way. So, but there's also concern about having using a protocol that might change without having us having any input into that. So if we could have assurances that the protocol is like maybe specified somewhere and that everybody's following the specifications versus, and also there are independent open source implementation of both sides, then maybe maybe can wait. No, there doesn't seem to be yeah, especially the upload, the download is the part that I'm most concerned about. Upload is also, that's the part is a paid Sylab service, but maybe there are others, maybe there are other registries that are using it that are not paid. So I guess the Linux Foundation themselves is they were the drivers behind that. They about the removal of that piece, because they don't want to have any depending on any protocols that might change without them having any input in it. So we have to be able to follow what their requirements are on that. But I think we could probably negotiate something to make that work.
Right. I think one of this does highlight something which is a little bit of a disappointment with regard to the announcement, which is that I mean, we look back in history and obviously we are completely in agreement with the fact that we forked without open discussion of that back in earlier in the year. But also that, if some of these things were concerns about the specific protocols, it's a little bit disappointing that we weren't included in that kind of discussion at all. But yeah, we'll see how things go forward, and hopefully, once you've got past the rename and the kind of frantic work there and stuff, then we'll see where we stand a bit further.
Yeah, I think those things can still be worked out on that, if in ways to satisfy the Linux Foundation and also make it good for all the users.
Okay. Does anyone else have any kind of input on this, or questions or anything? Okay, we're always available, and to those people who might be watching on YouTube, you're very welcome to come and talk to us about concerns, questions in the Slack, the Google group, or anywhere else you can find us. We've got an open item then for any other business or questions. I don't have anything. If anyone wants to raise any other thing at all, please go ahead. Okay, we'll call it a day then. Now, this will be posted shortly, and thanks for attending. Thanks especially Dave for dropping in.
No problem. Sorry I was late. I was doing an OpenXD mod upgrade.
Ah, right. Okay. I'm familiar with that in a past life. Okay. Thanks for dropping in, everyone. Like I said, we'll post this shortly. Have a great day and enjoy your weekend too when we get to it.